All right, welcome to this technology demo for our exponential regressions problems. So we remember that in our exponential regression PowerPoint, we were looking at this first set of values. So we know that the room temperature was 68 degrees in this room. And we were looking at this data set, which represents the temperature of something over time. So this was time, and this was temperature. And we were trying to make sure that we knew exactly what we needed to do as far as finding an exponential model for this. So we're doing an exponential regression. So let's go ahead and do that. So we know that the room temperature is 68 degrees. That's really important for us to keep in mind. So we're going to go ahead and hit our stat key. So hit your stat key, and you're going to want to press edit. And in your first list, you want to enter in your x values. So you have 0, 5, 10, 15, 20, and 25. So those are your y values. And then you want to, or your x values, I'm sorry, and then your y values will be 203, 177, 153, 137, 121, and 111. All right, now here's the thing. We want to make an exponential model, but our TI-84 can only do things in the form a times b to the x. So I'm going to do two functions and show you the difference between them. So let's just say that I was to take a look at this data right here, right? So I want to go second stat plot, turn my plot on, press on, and then I'll press zoom. Zoom 0 should be zoom fit. All right, so after playing with the window size a little bit, I was able to see this data here. Now, it appears as though this data approaches some line that is not going to be the y-axis or the x-axis. So we actually need to take that into account in our data. So we go back to stat, go over to edit again, and we know that the room temperature in the room is 68 degrees. Well, the liquid is not going to cool below that temperature. So what we're going to say is L3 will be equal to L2 minus 68, and press enter. So now this set of data will give us our normalized curve here. So this will allow us to actually get a good regression for it. So we press stat, we come to calc, we go all the way down to exponential regression, which is option 0. And we want to change our L2 to now L3. And I'm going to go ahead and store this in my variable. We go over to yvars, functions, y1. So this will store it into the y1 equals in our y equals key. And we calculate. And so this is what we'll get. And so if we go to our graph, we see that we have this nice function now, but it's too low for our data points, right? And the reason for that is that we used L3, so we actually need to go back into our function now and go to the very end here and say plus give it a second. So you want to add 68 to the end of that equation. Go ahead and press enter then, and go back to your graph. And now you see that this is a really good model for our data points. So that's the whole point of this entire process, is that we want to create a exponential model of our actual data. So what we'll see is that our exponential model should be y is equal to, and we can come over here, and we can copy down what our function was. So this was approximately 135.93 times 0.958 to the x plus 68. And that's what we got in our PowerPoint that we were looking at. So go ahead and apply this to our next set of data. Remember, your room temperature represents your asymptote in both cases. So make sure that you create some data that is shifted to be able to accommodate the calculator's needs. All right, if you have any questions, let me know. Have a wonderful day. Goodbye.